Hello, welcome to the hands-on exercise of LSA in Python. So in the previous session, we have discussed the mathematical and theoretical ways how can we apply the LSA in order to reduce the dimension of the original context or occurrence matrix, right? So in this session, I am going to explain you how to apply that LSA technique on the occurrence matrix, and also see the results, how the dimensions of the matrices are actually visible in our methods. So I'm going to use NLTK library to import the text corpus. We can directly use the text corpus available in the NLTK library. We can use different corpuses available. So we can test out with few ones. So I have tested out with brown corpus and try to create the TF-IDF vectorizers and had bit Handson over here. But we are not going to use this or use this inbuilt corpus. So I am going to create my own text corpus containing 5 different documents or context. You can also refer it as sentences. So I have created a text corpus with 5 sentences. So each one refers to one context. So C1, C2, C3, C4, C5. So now the text corpus is ready. Now what I am going to do, I am going to apply TF-IDF vectorizer. Why is this? Because the TF-IDF vectorizer will yield me a occurrence matrix, right? So it will basically yield a occurrence matrix. So why we need this occurrence matrix? To apply the LSA on that occurrence matrix to see the results, that reduced dimension results after applying that LSA. So I'm going to create this text corpus. Then I'm going to split the text corpus using a split function. Let's see how the document is splitted into words or in individual document in this form. Soon after this, what I am going to do, I am going to import the TF-IDF vectorizer from sklearn feature extraction.txt. So I will apply this fit transform on the text corpus which I have created. So let us have a look of occurrence matrix which is obtained after applying the TF-IDF vectorizer. So here it will indicate the dimensions. So let's say it has 1, 2, 3, 4 up to 9, starting from 0 to 9. So this is the dimension of the occurrence matrix, right? So what we will do, we will try to apply the LSA on this occurrence matrix. So for that we have a ready-made or a library available in sklearn.decomposition, and it is available in the form of a truncated SVD. So this truncated SVD is also referred as LSA. So we will try to import sklearn.decomposition, import truncated SVD. So I have initiated that SVD with only 3 components. We can set this dimension. I have a freedom to reduce the dimension of this entire occurrence matrix to my desired dimension. So in this case, I am trying to reduce this entire large dimension matrix or occurrence matrix to 3 dimension or a 3 column matrix to the end. So I am initiating that truncated SVD with n components equals to 3. Then I am trying to fit this TF-IDF vector or occurrence matrix to this truncated SVD. Then when I try to print that LSA, it will be giving me a final array. So here you could have observed that the dimension of this entire occurrence matrix has reduced to 3 columns, but each of them representing the certain vector value for each of the document. So here we have a 5 document. So each of these document will be represented with a certain vector value. As I mentioned in the demerits of the LSA, so the matrix which is obtained after the LSA decomposition or LSA, it is pretty much uninterruptible. So we cannot interrupt what these values are, but these are the reduced values of this entire document. So the 7 continent and planet are basically reduced to certain vector values, and this is definitely with a lower dimension when compared to the TF-IDF vector. Hope you understood the real-time application of LSA. Thank you.